All right, in this segment, I want to show you how to do the Friedman's test. I know there is an SPSS video that I've already put in here, which basically is the same, very similar to what I'm going to be doing. Using the same subject here, the same data set of relaxation therapy. Note earlier, I had said, that I had said that week 5 is severely skewed, and I think the skewness was like 2 point something. I think it was like 2.5 or something, which is really beyond the ±1 criteria that I had mentioned to you. All right. So while we met the homogeneity of variance and the correlations, meaning we met the sphericity assumptions, because we did meet the normality assumption for one of the observations, perhaps it is a good idea to do a Friedman's test here. All right. So how do we do the Friedman's test? All right. So to do the Friedman's test, you do this. Okay. The Friedman's test is the non-parametric statistics equivalent to the repeated measures or the simple repeated measures analysis of variance. All right. So to do that, you go to analyze, non-parametric legacy dialogue and K-related samples. K-related samples. So I've already gotten week 1 to week 3 here. I like that. And you notice that the default is Friedman's test. Okay. Go to statistics, and I suppose you can do the descriptives since these are actually continuous, but that one of these are non-normal. Okay. So again, if your observations are truly ordinal, or that it is continuous but skewed, then you may opt to choose the Friedman's test. All right. So continue. All right. Click OK. And this is what you have. Okay. Again, we have the means and standard deviations, much like we saw earlier. Okay. So no difference there. So we can bypass that. Okay. And then what we really want to look at is then the rank. Okay. Here is the mean rank. Okay. And then here is the chi-square statistics. Okay. Chi-square is a distribution that I think this is the first time that you may be hearing of the chi-square test. But these tests are equivalent to your t-test and your f-test. The t-test in all the t-tests, the one sample t-test, the correlated t-test, the independent sample t-test, or the one-way analysis of variance and the repeated measures analysis of variance. Okay. We have, so up until now, you've heard of the t-test and the f-test, and now we've got the chi-square test. Okay. So the Friedman's test is based on the chi-square distributions or the chi-square test. So at this point, don't worry too much about what these tests are. They're just based on just the chi-square distribution. So clearly, with an n of 9, okay, so you have a chi-square of 31.55 and a p-value less than 0.001, which suggests that there are differences between the rankings, the mean ranks of the week. Okay? What it simply means is this, that if you look at the mean ranks, there are differences between at least two of these weeks, all right? So if you want to find out which pairs of week are most likely different, it's probably going to be week 1, okay, since this has the highest mean rank, and week 4, since that it has the lowest mean rank. So even if you don't do any further analysis, you can at least say that week 1, okay, represents the highest number of hours of weekly migraine headaches, and week 4 represents the lowest number of, in terms of ranks, the lowest number of migraine headache for the week. Okay? So at the very least, that's what you can say, okay, if you don't do any further analysis. But one of the things that we obviously are interested in is is the relationship between time and migraine headaches, which brings us to the issue of effect size. And then, of course, we want to see if, in fact, week 2 is different from week 3, or week 2 is different from week 4, or week 3 is different from week 5. Okay. So we need to do pairwise comparison. All right. If you look at some text, there is a more traditional way of doing this, and that is to do the Wilcoxon test. Okay, so many Wilcoxon tests. For example, they will do, so you go to analyze, you go to non-parametric, and then you go related samples, or rather, hang on, actually not. You go to analyze, you go to non-parametric, you go to legacy, and then you go to two related samples. Okay? And what you do is you go pair by pair. So this is Wilcoxon. So week 1, week 2, week 1 to week 3, okay. Week 1 to week 4, week 1 to week 5, all right? And then week 2 to week 3, week 2 to week 4, week 2 to week 5, okay? And then, so now week 3 to week 4, and then week 3 to week 5, and finally week 4 against week 5. Okay. You remember doing this when you were doing the Wilcoxon test as the non-parametric equivalent to the correlated t-test. So it's Wilcoxon, and if you go okay, this tells you exactly what excuse me, what pairs statistically significant. Okay. So you can see here week 3, week 3, no difference between week 1 and 2. Okay. But week 1 and 3, there are difference. Week 1 and 4, week 5 and 1, week 2 and 3, week 2 and 4, week 2 and 5, week 3 and 4, and those are the pairs of that are statistically significant. This is probably the more common or more traditional way of looking at pairwise comparison or looking at the differences between. Yeah. But I think in the SPSS video to run the Friedman's test, it shows you a much more straightforward way of doing the Friedman's test. It gives you both the effect size as well as the pairwise comparison. Okay, so let me show you how that is done. Okay. So to do that, you go to Analyze, okay. Go to Non-Parametric, but instead of going to the legacy dialogues, you just go to Related Samples. Okay. And you click Customize Tests. Now you go to Fields first, excuse me, go to Fields. Okay. And you do week 1 to week 5. Okay. All right. And then you go to Settings. Okay. Click Customize Tests. Click on Kendall's coefficient of concordance and all pairwise. And then you pick one. Okay. And this is your the test. This is actually the Kendall's coefficient of concordance, and you see that it is statistically significant, which simply means that there are differences between pairs of weeks. So what you do then is you double click this, okay? And this is what you have. Okay. And so you noticed earlier the test statistics of chi-square 3.31.54. You saw that earlier. Okay. Here, right here, when we did the Friedman's test, you saw that right here. Okay. So the chi-square test of 31.545 or 31.55, you saw that there. All right. So we've seen this right here. So the Kendall's W is 0.876. This actually represents your effect size. Okay. This represents your effect size. Okay. So this is represent your effect size Kendall style, and we read this like the Cohen's D, where 0.2 is small, 0.5 is moderate, and 0.8 is large. Okay. All right. So so that's so that is your Kendall's W, which is a measure of effect size. 0.2 is small, 0.5 is medium, 0.8 is large. All right. So so that gives you a measure of effect size, and as I've said, you read it you read it much like the effect sizes or the candle style. All right. So, how do we look at the pairwise comparison? All right. So if you go down here, if you go down right here and you click on pairwise comparison, okay, it now gives you the pairwise comparison. All right. So according to the candles, I mean to this analysis, the Friedman's test, the comparison, pairwise comparison, the differences are between week 2 and 4, week 1 and 4, week 2 and 5, week 1 and 5, okay, which is slightly different than what I had showed you in the sample write-up. Okay, so this is the Friedman's way, an illustration of the how you run the Friedman's test, how you get the effect size, as well as how you get the pairwise comparison. And again, slightly different than the repeated measures analysis of variance, but it does show you how it is done. All right. Okay. So again, when you look at the assignment 6, when you try to run and you test for all those assumptions, you can then choose to decide whether to run the one-way repeated measures analysis of variance, or the simple repeated measures analysis of variance, or the Friedman's test. All right.